Welcome all to another lecture on cloud computing. Here we are going to see distributed computing. In the previous lecture we had seen how parallel computing was, and in this lecture we are going to see what distributed computing has in its store. So firstly, understanding distributed computing. A distributed system is a collection of independent computers that appears to its users as single coherent system. So ultimately it will be acting as a single coherent system. You can see here a distributed system is one in which the component located at network computers communicate and coordinate their actions only by passing messages. So actual interaction is taking place by message passing. And here the components are located at different locations. That means they are network computers, that is interconnected computers who communicate using passing of messages. The components of a distributed system communicate with some sort of message passing as seen in the previous line. Now this is the layered view of a distributed system. So basically at the lowermost level we have hardware, then we have an operating system of each hardware, then these two constitute the network and hardware layer. Then comes middleware, and finally comes the application. So these are the four layers present in a distributed system. At the bottom, hardware, followed by operating system, then comes the middleware, and then comes the applications. We'll be seeing each of these in detail. So bottommost layer is constituted by computer and network hardware, and they constitute the actual physical infrastructure. It is the actual physical infrastructure. These components are directly managed by the operating system of your machine, and it provides basic services for inter-process communication, process scheduling, management, resource management, etc. All right, and these two layers form the platform on top of which a specialized software is deployed, and it will be turning a network computers into a distributed system. So these two layers is the base platform, and over which we install specialized software which ultimately turn your connected computers into a distributed system. And at this layer different protocols also work, like at the operating system level IPC services are implemented using protocols like TCP IP protocol, UDP protocols, all. So all these protocols work over this layer. Now comes the middleware. The middleware layer leverages such services to build a uniform environment for development and deployment of distributed applications. When we will be moving into the cloud, we will be seeing in detail what middleware is. So it's just a introduction, and it says that it will be allowing us to build a uniform environment for development and deployment of your distributed applications. By relying on the services offered by operating system, middleware develops its own protocols, data formats, programming language frameworks for development of distributed application. So you are actually developing your application over this middleware. The top of the distributed system stack is represented by the applications. So finally the applications that are developed as distributed ones. So they are designed and developed to use the middleware. So these applications that you have developed, actually they will be developed to use the ultimate middleware which is giving access to the physical machines. Then these expose features of these applications obviously in the form of GUIs which are accessible locally through internet or web browsers. So this final layer of the application layer, all the features of that application will be exposed in the form of GUIs which are accessible locally to a system or through the internet via a web browser. Now going to a quick recap of these components. Hardware and operating system layer, they make up the backbone as you have already seen. Then backbone of what of these data centers or any applications that you are going to build, where rack of servers are deployed and connected together through high speed internet connectivity. The infrastructure is managed by operating system, which provides the basic capability of machine and network management. Then the core logic is implemented in the middleware that manages the virtualization layer. So the virtualization layer, which actually provides us the access, is handled by the middleware. Virtualization layer is deployed on the physical infrastructure in order to maximize its utilization and provide customizable runtime environment for application. Then again, different facilities to the application developments are provided through the middleware. Now all the facilities are accessible through what? Web 2.0, that is our internet interface. Range from virtual infrastructure building and deployment to application development and runtime environments. So all the facilities are made available through the internet. Now moving on to the distributed systems, they are actually divided based on two different styles. First one is software architectural styles and the second type is system architecture styles. Now what software architecture styles do is they provide or they are based on the logic organization of the software. Now system architectural styles, all those styles that describe physical organization of distributed software systems in terms of their major components. So these are the two methods in which you can actually classify the distributed systems. We will be seeing each one in detail. So before moving into the components, we will be, these architectures, we need to understand two key terms in a distributed system. First one is a component and second one is a connector. A component represents a unit of software that encapsulates a function or feature of the system. So what a component means is a unit of software and each component will have a functionality or a particular feature. Examples of components can be programs, objects, pipes, filters, all these. Okay. And next term is connector. A connector is a communication mechanism that allows cooperation and coordination among the components. Different from components, connectors are not encapsulated into a single entity. They are implemented in a distributed manner over many system components. So each of these connectors are implemented over different components and each component is actually doing what? It encapsulates a proper functionality, and connectors allow cooperation and coordination and communication among the different components. All right. Now we have seen here we have software architectural style and system architectural style. So just introducing you about the different software architectural styles. There are various: data centered, data flow, virtual machine, call and return, independent components. So these are the five actually software architectural styles which are further subdivided and each has to be seen in detail. So different software architectural styles are, that means the different distributed systems can be classified as data centered or data flow oriented, virtual machine systems, call and return based systems, or independent components. So we'll be seeing each of these in detail. So in our next lecture, we are going to see what each of the software architectural styles are in detail. So these are them once again: data center, data flow, virtual machine, call and return, and independent components, plus at least two from each of these. All right. So thank you. See you in our next lecture.